Alright, so here's a demo of Aurora from SmartMatrix Jason Kuhn running on 3 different displays. You actually see 4, but the 2 higher res ones are mirrored, running the exact same thing. They're running on 3 different CPUs as a result. I'll start with this one. That is my old shirt, and there's a tracing paper as a diffuser here, running on that ESP8266. That's an Ethernet cable bringing 3 different lines in parallel, so I get a better refresh rate, running 256 pixels at a time on 3 different lines. It's supposed to be faster, but honestly I don't quite see the difference on these demos compared to a single line. So here running 1000 pixels on a single line on that other ESP8266, and I mean, it's maybe not exactly as fluid, but for the average user it won't probably show that much. Here you now have a lot more pixels, over 6000. Those are running on RGB panels. You have 3 panels, 1, 2, and 3 that I joined together, and that's the mirror running in the back. So that's running on an ESP32 here, and you can see here that big ribbon cable going out with 14 different lines required to run out this. And power wise, we're running not even an amp here, whereas this one's actually running more than 1 amp actually it's not even a good example here because that's running a lot more pixels at the same time. But basically the point is running 1024 pixels of NeoPixels is still using more power than running 12,000 pixels of the same power here, power line. So definitely RGB panels are much more efficient. They're not as bright, right? It's kind of hard to tell on camera, but you can definitely tell that NeoPixels are more bright. But they're not, like the ratio in between, right now running 1.4 amps versus just 1 amp, right? So you're basically running 12 times more pixels, maybe a ratio of 14 in power use, which is huge. Alright, so now I'll just shut up and show the demos in those 3 form factors. Again, 768 pixels here, 1024, and over 6000 here. So that is an incremental drift. That would be incremental drift 2, called rows. That one shows very different ways depending on how big your screen is. I'd be like the version running on the right, and it's the same code, it just adapts to your display size. Then that's pendulum wave here. That would be radar. Radar doesn't look as good on displays that are on square, sadly. It's definitely meant for a square display, but hey, you can still run it. This one is called Spiral, and it works well on the smaller displays. It's just not enough pixels to lit on the higher res display. Now we have Spyro, and strangely Spyro actually doesn't work on a 3232 display, which is what used to be supported by SmartMatrix. It's probably a bug in the code. I don't think it's my bug, I don't think I've changed it. It's actually very cool to run for a long time, but I'm making this demo a bit shorter. This one is Swirl. Again, looks nice in low res, just not really meant for a very high res display. I have to double the pixels. I just didn't bother because I just don't like that pattern as much. Now we have Wave. This one's called Attract. It's quite nice, especially in high res. High res looks much nicer on this one. Then bounce. Cube. Cube was challenging actually. I definitely had to change the code a little bit for the display size, and the fade is different, so I get a bigger trail on the higher res display. That one's called Flock. It actually simulates predator in a different color running after a flock of insects, birds, whatever you want to call it. So you can see on the right the little green now turning blue, trying to find some food. Lava is also nice, especially with the latest change that Jason did, where it can actually flow sideways more. And we're back to incremental drift. I'll let it run a bit because it's quite nice. And again, incremental drift rose, which is also quite nice.